So moving away from log equations into exponential equations, we can't deal with exponential equations without invoking logs. So the way that's going to look, you take question A, 4 to the x equals 605. Now, in a previous method, we would have tried to turn 605 into a base of 4, which is actually impossible to do. So this is why we need to use logs. We have an x exponent on the 4. Means we don't have 4x, we have 4 to the power of x. So if this was 4x, we just divide both sides by 4 and be done with it. We can't deal with that with exponential equations. We need to actually find a way of taking that x out of the exponent, and the easiest way to do that is if we can log both sides. And what that accomplishes is now that we have a log on the left, we can invoke one of those laws of logs, take that x exponent down, turn it into a coefficient, so we have x log 4 equals log of 605. Now at this point, might be a little confused where to go, but a calculator is going to be a really good tool to have right now. Every calculator has a log button on it, and that calculator is always in log of base 10, which is why when I logged both sides in this step right here, I picked a log of base 10 knowing that I'd be going to the calculator in a couple of steps. You should always use log base 10 when you're doing this because it allows you to use the calculator. So go to the calculator, you type in log of 4, you should get 0.602. Actually 0.60206 if we're going to go a few more decimal places. If you don't, try typing it in a different order. Try typing 6 log, or if you have a direct logic type, go with log 6 and then equals. You should get 0.60206. We'll do the same thing on the other side. We'll type in log of 605, 2.78176. And to solve for x, we just need to divide both sides by 0.60206. And rounding to 2 decimal places, we'd get that x equals 4.62. Moving on to B. The only complication that we have with B is this 8 that's multiplied. And because of that, we shouldn't log both sides right away. We should get it down to just the exponential function on the left. So easiest way to do that, if we divide both sides by 8, cancel those 8s. We end up with 3 to the power of 2x equals 71. So now the process goes exactly the same as in question A. We'll log both sides. Use that law to bring the exponent down out front as a coefficient. Step over to the calculator. If we do log of 3, we get 0.47712. Do log of 71, we get 1.85126. Left is a little bit more complicated, but not that much. We have the 2 times the x times the 0.47712. So if we go ahead and multiply the 2 and the 0.47712, we would get 0.95424x equals 1.85126. 2.126. Solve for x, divide both sides by 0.95424. And again, 2 decimal places, we get that x equals 1.94. With question C, we don't have an 8 multiplied out front. We don't have anything other than 2 exponential functions equaling each other. Doesn't really complicate things much. It just increases the length of the question. So we can go ahead and just log both sides. So we log of 4 to the power of 2x minus 1 equals log of 3 to the x plus 2. Use the law to bring the exponents down out front. Now we have 2 terms in each exponent. So let's make sure we put brackets around them. Flip over to the calculator, deal with those logs, work them out. So log 4 would be 0.60206. Log 3, 0.47712. And then we'll have to distribute that decimal into each of those brackets. So 2x times 0.60206, we can do the 2 times 0.60206 is going to give us 1.20412x. Multiply into the minus 1, so subtract 0.60206. Do the same thing on the right side, distribute in, so 0.47712x plus 0.95424. This is nothing major, we just have decimals to deal with. We need to isolate x, so if I'm going to move the 0.47712x to the left side, I'll subtract it. I get 0.726 x minus 0.60206, which will equal 0.95424. That is a 726. Move the 0.60206 over to the right side. We will get, I'll do this up here, hopefully I have enough space to squish it in. We are going to get 0.726x equals, and we'll take the 0.954, add the 0.60206. We get 1.5563. Divide both sides by 0.726, go into 2 decimal places, we get that x equals 2.14.